Hello guys, and welcome back to chemistry class. And of course today it is glaring, we are talking about Charles' law. If you have not started the episodes on kinetic theory of matter with us, please go back to the two previous episodes on this channel on JAMB chemistry, and please follow us through. In the last episode we talked about Boyle's law, but here I'm going to treat Charles' law exclusively. All right, join me. So Charles' law attempts to explain the variation of volume of a given quantity of gas to the temperature when the pressure is constant. All right. So Charles' law seeks to explain or attempt to explain how volume of a given quantity of gas varies with the temperature when the pressure of the gas is kept constant. So in Boyle's law, we kept what? We kept temperature constant, but in Charles' law, we are keeping pressure constant. In Boyle's law, we kept temperature constant. In Charles' law, we keep what? Pressure constant. So this must stick to your head. All right. So now, Charles' law seeks to what? Explain other things. Like for example, it tells us that what? All gases expand equally on heating. All right. Charles' law tells us that what? All gases expand equally on heating. And what does it mean? It means that at constant temperature, each degree rise in temperature of a definite mass of gas expands 1/273.5 of its volume at 0 degrees Celsius. So when I say that all gas expand equally on heating, this is what I mean in earnest. At constant pressure, because Charles' law keeps what? Pressure constant. At constant pressure, each degree rise in temperature of a definite mass of gas expands 1/273.5 of its volume at 0 degrees Celsius. These are the salient points. So for simplicity, Charles' law says that at constant pressure, the volume of a given quantity of gas is directly proportional. Let me bring it out. Charles' law, for simplicity now, Charles' law states that at constant pressure, the volume of a given quantity of gas is directly, in Boyle's law we talk about inverse proportionality, but here we talk about direct proportionality. Is directly proportional to its temperature. All right, so this is what Charles' law states in earnest, right? Like I said earlier, Charles' law attempts to explain the variation between volume and temperature when pressure is kept constant. So Charles' law is stating that at constant pressure, the volume of a given quantity of gas is directly proportional to its To its temperature. Is directly proportional to its temperature. This is what it's talking about in earnest. So now mathematical representation of this will mean that, let's see. So mathematically, we know from the definition that volume is directly proportional to temperature. This is not inverse proportionality. If it was inversely proportional to temperature, we would have said V is inversely, right? But this is a direct proportionality. All right, so we introduce a constant. So introducing a constant now, right? So that V now becomes what? KT. Excuse me. So like I said earlier, when we introduce a constant, the sign of proportionality disappears. And then of course, introduce a constant. So V is KT, and this means that K now is equals to V over T. All right, this means that K is equal to V over T. I'm divide both side by what? By T, because so that I can leave the constant in one side. K will be equal to V over T, and this means that what? V1 over T1 is equal to what now? V2 over what? T2. It's equal to what? V3 over T3, and so on and so forth. If you are considering what several other number of gases. All right, so now this means that this is very important to us, and this is very important to us for calculation purposes. According to our exam, as it concerns our exam, this is very, very what important, and so we must know them. So we already know here that V is equal to what? KT. All right, this means that what? That V over T is constant for an ideal what? Gas. Just like Boyle's law, Charles' law also only what works for what? For ideal or imaginary what? Gases. And this means that what? That V over T is constant for an ideal gas that what? Keeps pressure constant. This means that at constant pressure, V over T is constant. V over T is constant for what? For an ideal or imaginary gas. Let's take an example. Let's use the table to explain this. For example, if you have volume in unit, we have temperature unit, then we have V over T. Let's say this is 100, this is 80, this is 60, this is 40, this is 20. Then of course, let's say this is 20, then this is let's say 16, this is 12, this is 8, this is okay, this is 4. All right. So now I want to show you how the volume varies with temperature, and when V over T is what? Is constant. All right. So now let's continue. So now if you see here, this is 100, this is 20. V is 100, T is 20. That means V over T now will be what? 100 over 20. This will be 5. Is 80 is 16. 80 over 16 is 5. 60 over 12 is 5. That is V over T. 40 over 8 is 5. 20 over 4 is also what? 5. Now, two things are clear here. One, that as the volume is decreasing, the temperature is decreasing. You know, when we talk about when we discuss what Boyle's law, as the what as one unit, as pressure was what was increasing, you see that the volume was what was decreasing, right? So as one is increasing, one is decreasing. That is because it is an inverse proportionality. But in this case, because it is directly proportional, because what the volume is what directly proportional to the temperature at constant pressure, because it is directly proportional, that means what is affecting V will affect what T. Whatever is affecting V will affect what T. All right, in the same manner, because of that direct proportionality. All right, so when V was decreasing, right, T was decreasing. That is the first observation you should make here. Now, in the second phase, now V was changing, T was changing, but V over T remained what? Constant. This means that for a given what mass of gas, or for a given quantity of gas at constant pressure, right? At constant pressure, V over T will always be constant. All right, now before we take a question, please know that when solving questions that has to do with Charles' law, right? The temperature, the unit of the temperature must be in Kelvin. You must convert the unit of temperature to what? To Kelvin before you can what? You can begin to solve. Let's take a question, and I'm going to what for this part so that what we can just what attempt the question on the board. Now let's see. All right, welcome back. Like I've said, I just want to, we're taking this example from the O3SCHOOLS JAMB app to make you what? See how you use the formula to solve questions, just like we did with what? With Boyle's law. So on your own part, go to the O3SCHOOLS JAMB app, use the question search feature, and then search for questions on Charles' law. You will see a lot of them come out. Answer them, solve. So as we're taking each topically, make sure that you are solving questions. Use the app has the question search feature for you alone. So you go to the question search feature, select chemistry, then what? Search for Charles' law, for Charles' law rather, and then you see questions on that Charles' law coming out for you. You answer them, you feel fulfilled, you march on to the next episode. So let's quickly do this. But before we do this, There's a graph. The graphical representation of Charles' law is very easy. So you have something like this. All right. Then of course you have something like this to dash going up. I think you have something like this dash going up. It's a straight line isobaric graph. It's a straight line isobaric graph. It's called a straight line isobaric graph. Straight line. All right. So let's call this one P1, call this one P2, call this one P3. Yes, what V, right? And this one is what is T. All right. This is minus 273 degrees Celsius. See, somewhere here should be 100. Yes, 0 degrees Celsius. All right. So you can see the temperature going in this direction, right? Volume going up. All right. So this is supposed to be straight to before I draw another thing. Okay. So this is a straight line isobaric graph showing the variation of volume with temperature at constant pressure. For here, I think that is basically all you should know about it. So just know that it crosses. This is minus 100 degrees Celsius. What is 0 degrees Celsius anyway? So simple as ABC, easy peasy. All right. So now let's quickly attempt this question we have on the board, right? So we're given a question and it says at constant pressure, a certain gas sample maintained at 43 degrees Celsius occupied a volume of 500 cm cube. All right. That means solution now. All right, we are giving what T1 to be what 43 degrees Celsius. Now I told you when it comes to Charles' law, you don't solve in what in Celsius, you solve in what in Kelvin, right? So doing this now, because of what now 43 plus 273. So to convert from Celsius to Kelvin, simply add 273, and then I call that will give you 316 what Kelvin. All right, so we're giving volume. V1 is what 500 centimeter cube. Now, they say the first question say at what temperature in Kelvin will it occupy at 800 degrees Celsius? So we're looking for what T2. T2 is unknown, but of course V2 is giving us what 800 centimeter cube. All right, that means what we can now use our formula to solve for what for T2 from our formula from Charles' law. From Charles' law, please, Lao, I was speaking. I'm begging you. I'm doing this because I'm only doing this because what I'm explaining to you. In your JAMB, you should be as fast as anything. Your JAMB, baby, fast and know what you are doing. In fact, just be moderate, so that you don't go and say I was one that told you to be fast, right? Don't be moderate. Moderately do things. All this does not concern you. By one side, you're going to know that V1 over T1 is equal to V2 over T2. What is V1? V1 is 500. 500 over what is T1? T1 is 43 plus 273. You add 316 is equal to V2. What are we looking for? We're looking for T2. So V2 is 800 over T2. Cross multiply. T2 is what? 316 times 800 over 500. You get the answer 500 and something. You get? It's as simple as that. That is how you solve smartly. You don't do all these things. Some of you will still go and carry one paper now and be doing from Charles' law. You will sleep there. Please do not waste your time on questions that are as cheap as this. All right. So you know what to do. You know that it is Charles' law. You apply your formula and then you are good to go. So let's do this. So from Charles' law, we know that what V1 over T1 is equal to V2 over T2. All right. So we're looking for T2. So we can cross multiply. This means that T2 is equal to what now? V1, sorry, V2 times what? T1 over what? V1. So let's do that. If we do that, we're going to have, what is V2? V2 is 800. What is T1? T1 is 40. Is 3. See, you don't solve with 43. If you solve for 3, you are wrong already. So it's 316 with 316 over what is V1? V1 is what? Is 500 here, right? So over what? 500. So if you do this, I think your answer will give you 515 point, right? Sorry, 505.6 Kelvin. All right. So to give you something around 505.6 Kelvin, please cross-check the answer. Anyway, then Now that we have solved for the first part, they say at what temperature in Kelvin will it occupy at 800 centimeter cube? All right, so this is what our value. Now, the second part say what will be its volume at 68.8 degrees Celsius? Its value at what? 68.8 degrees Celsius. So now let's do that. Now we are given, we see no V1, right? We know V1, right? We know we're not looking for what? For V2, right? Because we know V1. We're not looking for what? For V2. All right. So this one now, this 800 centimeter cube has covered for this question. So we'll say what will be its volume at this temperature. So the first thing you do, that means I give me another what? I give me what? T2 to be equal to what now? 68.8 degrees Celsius. So what do? Convert to what? To Kelvin. If you convert to Kelvin, that will be what? Equals to 68.8 plus 273. That will give you what? Add, I'm going to have 341.8 Kelvin. All right. So having known the T2, they say we should look for V2. So we know V1. So for our formula again, we're looking for what? V2. What is V2 here? Cross multiply here. V2 will be equals to what now? V1 times T2 all over what? All over T1. So if you do that, what is V1? V1 is 500 times what is T2? T2 is what? 341.8 all over what is T1? T1 is what? 316. So if you do this, I'm going to have 540 centimeter cube. All right. So it's as simple as ABC. Simple as ABC. Just know your formula and then you know what to do. You are good to go. And importantly, you must know what is kept what constant. So you can see at constant pressure, don't just already know that it's Charles' law. It's Charles' law. Provided you talk about constant pressure, just know it's Charles' law. All right. So just bring your formula by the side and what? Find what's your values and we'll start with solving immediately. Do not need to waste any time. All right. So we give you an additional tip. An additional tip that will help you not just only when solving questions in gas laws, but for the whole of chemistry itself. For the whole of chemistry, when solving questions in chemistry, it's very, very important you know this, right? So please, before I do with that, please make sure that what you have subscribed to this YouTube channel. Subscription is free and it helps you a lot, so that once we release a new video, you'll be notified that we have released a new video. So click on that red subscribe button just below. It's free. It's free to do it. Right? You are using it to encourage us and you are using to what? To help yourself, right? So that once we release a new video, once we upload a new video, you'll be notified on your phone that O3SCHOOLS has uploaded a new video. All right. Then of course, do not forget to like. Once you click on the like button below this video, that like button, click on the like button. Click it now, please. As you click on it, right, other students like you will easily find our videos and they will learn so that they can pass. Do you like when they announce that student failed JAMB? No. So please click on the like button immediately and do not forget to share to your classmates, to your friends, to your families, members who are preparing for this examination. All right, so now let's go. Now, I'll give you some unit conversions that will help you a lot in chemistry. So number one is 1000 mil is equals to 1000 cm cube is equals to 1 dm cube is equals to 1 liter is equals to 10 to the power -3 meter cube. All right, please know this and know peace. You must know it on your head. That's very easy. It's simple to know. 1000 mil is equals to 1000 centimeter cube. It's equals to 1 dm cube. It's equals to 1 liter. It's equals to 10 to the power -3 meter cube. Also, 1000 liter is equals to what? 1000 dm cube. Is that not true? Because 1 dm cube is 1 liter. That means 1000 liter is also to be 1000 meter cube. 1000 dm cube, and this will also be equal to what? 1 meter what cube. All right, get that. Now, if I give you what? A unit in Kelvin, you want to convert to Celsius. What you do? Subtract 273. So I will say that what? T in Celsius, temperature in Celsius, plus 273 Kelvin, right? Or plus 273 is equal to what? Temperature in Kelvin. You get me now? So if I give it temperature in Celsius and you are looking for the temperature in Kelvin, just simply add 273, right? So if you know temperature in Kelvin, right, minus 273 will give us temperature in Celsius. All right, simple as ABC also. Are you there? So now, another one important one you need to know is that 760 millimeter mercury is equal to 760 torr. It's equal to 1 atm. That's 1 atmospheric pressure, and it's equal to what? 101,325 Pascal. And this is also equal to 101,325 Newton meter square. Please note that and no peace, right? 760 millimeter mercury is 760 torr. It's 1 atm. It's 101,325 Pascal. It's also 101,325 Newton meter square. This means that what the Pascal is equal to what? Newton meter square. You must know that. Know that. Please know that. So that when I give you a question and you want to convert to be a thing of what the past for you, it will be as easy as anything. All right. So there's something called room temperature. New room temperature is what? 25 degrees Celsius. Know it. And this is equal to what? 298 Kelvin. All right. Know that. Then body temperature. Body temperature is 36.9 degrees Celsius. Some people call it 37 degrees Celsius. But if you convert to Kelvin, to give you 310 Kelvin. All right. We also have something we call standard temperature. Standard temperature is 0 degrees Celsius. All right. So in Kelvin is what? 273 Kelvin. All right. It's as simple as ABC. Then of course we have standard pressure. Standard pressure is what? 760 millimeter mercury, or we call it what? 1 atm. All right. So please, all these things you are expected to know as a student. You are expected to know as a student, please, because when you see calculations, an examiner may just want to a simple question, but he may just give you another unit and tells you to give the answer in another unit. And because you do not know these conversions, you just fail that simple questions like that. You just feel woefully like that. And you'll be saying you pass because you don't know. Because you don't know what you don't know, you don't know. Right? So please note these things on your head, right? Memorize them, right? Use them to solve questions, especially room temperature. Right? Maybe you're giving a question now that has to do with temperature, and then they say maybe T1 is room temperature, right? Because you do not know what room temperature is. What will be room temperature again? No, because you don't know it now, you feel the question. So please, room temperature is 25 degrees Celsius. Standard temperature is 0 degrees Celsius. All right. So standard pressure is 760 millimeter mercury, which is 1 atm. All right. So with this, I'm sure that you can be able to approach any question and can be able to deal with it adequately. Please do not forget to subscribe to this channel. And my name remains Owolabi Thank or aka MC Owoblo. And I will see you in the next class. Thanks for watching.